Hi guys, I welcome you to my channel. Again, I showed up to you, and I'll be solving this question 124 binary tree maximum path sum. Very interesting question, and it is marked as hard. So let's solve this question. So first, what let me read the question. A path is a binary tree. In a binary tree, is a sequence of nodes where each pairs of adjacent node in the sequence has the edge connecting to them. मतलब what is saying that it's like a path will be called a sequence of node, and nodes are connected with each other with the like adjacent node are connected with each other with the like edge, right, with the edge. You see here edge. So a node can only appear in sequence at most once, so you do not we can't have duplicate nodes, and note that part does not need to be passed through the root. So this 1527 is also a path, a valid path, because sum is 42. So I have to what I have to do, the path sum of the path is sum of all nodes value in the path. So basically what path sum is, the path sum is the sum of all nodes. Like here path sum is what, 3 1 4 2 what 6, right? So path sum is 6. So path sum is the sum of all nodes, nodes value in the path, right? So what I have to do, I'll be given a root of binary tree, and I have to return maximum path sum of any non-empty path. I have to return maximum path. So in here, what is the maximum path? 1 2 1 3, right? And here, what is the maximum path? 15 20 and 7, and sum of them is 42. Why we are not taking 9? Because we have minus 10 here, right? So let's solve this question. To solve this, let's understand first. So I'll be opening Google Sheet, Google Doc, sorry. And here what I have done here, I'll do. Uh, what is the question I have given? I am given that root, right? A root. I'm given a root, okay, and I have to find the max path. Let me draw this small tree. So let me draw it. Maximum path. It's a binary tree, not a binary search tree. So anything can any value can be on the bottom. So yeah. So this is a tree. I'll take another like 1 2 3 null null 4 comma 7. I consider this as a tree. Okay. Now I have to find maximum path. So you see, what we can assume here, I also first time I could not understand how to find out, but here we see here ki if somehow we go to the left most of the root, and if you go right most of the root, left most of the root is 2, right most is 7, and if sum all of them, we get a bigger path with bigger value, like bigger path will get bigger path, but are the value is also bigger, we don't know, but we will get a bigger path, right? There's a 2137, this is a bigger path. So you see here, try to understand key and see, this is a root. Now if you could go to subroot, what is the bigger path here? 473 437 7 3 10 10 4 14. The bigger path is like bigger path sum is here, path sum is 14, right? Bigger path sum is 14, right? So sorry, bigger path sum is 14 here, 4 3 and 7, right? So what you understand here ki if you could find uh, path sum at each subroot level, and we try to find it each subroot level, and we will just merge it, or we'll just sum it to get bigger path sum, right? So see here, at root level, consider this is subroot 4, this is root 4. What is the max path of this 4? So on the left of 4 is what, 0, and right of 4 is also 0. So max path till here to after 4 is 0, and till 4 is 4, right? Same with the 7 as well. For max path on the left, right is also 0, right? So both the case is 0. So what both will return? Both will, it will, on the right one it will return 7, on the left one it will return 4, right? So what will the max of both of them? So max will be 7, 3, 10. This is the max one, 7, 3 and 7, right? Not 4 and 3. But if we could use the subroot 4, 7, 3, am I getting the max path? Let's see, 4, 3, 10, 4, 3, 7, 7, 7, 14. So 14 is the max path, right? It is greater than 4, greater than 7. So I assume that 4, 3, 7 is a max path. So now when we are returning back, we do not have to take subroot. We have to take either left, either right of the subroot. We can't take both. I hope I am able to clear your doubt. Okay, when you are going back to the parent to report that what is the maximum path, you can't take the sum of all three. You have to take either left or either right. So I want to return the maximum path for 3, subroot 3, right? So subroot 3, so what will happen? We have to take either 370 or 47430. Which one is max? 370. So I will return max of left or right plus root. Correct, no? Yeah. So max of left plus right plus root. So max of left and right is 7, and 7 3, what is 7 3, 10. So 3 have max path 10. So we'll go up. So on the right of one is 10, right of one is 10, and left of one is what, 2, right? So what is the max path? 10 plus 1 plus 2, that is 13, right? But we have max path some called 14, right? But that's why we will not take as answer. We will take this 437 as a max path and we'll turn the answer. So I hope you am able to understand. What we have to remember it is that uh, find the max sum path on the left and find the max sum path. This is the point we have to remember. This is the pattern we have to remember. Find the max sum path on the left, from the left, and find the max sum path from the right. Find the max sum path from the right. Find the max sum path from the right. Right, and second pattern is that merge them to root to update the max path sum, and this is the part, and other part you have to do, merge them to root, basically sum them to root root dot val to update the max path sum, and while returning we will return what? Return the either of left or right, that either max of return either max of left comma right plus 0 plus root dot val. And one doubt we have here, what if that we get negative value? What if that we have negative value in the root? Then when you are going to return, negative will impact the sum, right? Root dot val. Negative will return the sum, right? Negative value will impact the sum of the root, sum of the max path, right? So we can use that. If none of them is positive, at least we take 0, because otherwise this will affect the root value. That is the pattern we have to remember. For each subroot, we'll try to find the max sum path, right? Like we find the max sum path from left, max sum path from right, and sum them to update the max value, and return either left or either right max value. That's it. Let's code it. I hope I'm able to explain you. If not, just let me know where I'm like doing mistake, or where my thought process is not meeting with solution. Let's code the question. So what we have to do, what we have to check first? Check that if root is defined. If root is not defined, return none. otherwise we have return max path. So what can we do here? We can create a value self dot max sum. For now it will be the negative infinity, like smallest one, right? Now we have max sum path. Now what I'll do here, I will do a dfs, yeah, max sum, it is dfs max sum. We will have self, which will have self and root, and it will return me the int value. So it will return int value. So what we have done, we have to do right and then left. So if not root, let me check here, if not root, then return 0, right? If there is no root, I'll return 0. Like if there is no root, like in the case of 9, if we do not have left and right of 9, right? So we return 0. Otherwise we got the value, just say like we got the value, like current val is equal to root dot val, right? We got the current val. Now we go to left and right. So left val will be the max sum of root dot left, and right will be the right val will be the max sum root dot right. We'll go left, we go right, right? And we have to update the max path as well, max sum as well, right? So I have to update this. Max sum will be the self dot max sum will be the self dot max sum will be the max of self dot max sum, and left plus left val, right left val plus right val plus root dot val, root current val, root dot val, current value. Either this either like maximum is bigger, or left plus right plus current value. Why you have done that? Why I have done this? Because there is chance that subroot is also a max. Subroot can also give the max sum, right? Here is the subroot. This is 10 is the root, but we have 20, 15 and 7, and 15, 27 is yielding 42, and this is max, right? So this is max. So there is chance the subroot also give. That's why I'm showing the value in the global variable max sum, where I'll just updating the sum, just checking that if there is subroot which is greater than the current max sum. If yes, I will update it. Now what I'll do here, I'll return the value. So you see, we have to find the max sum path, we have called left. We have find right sum path, we have called right. Now I have updated the max sum path. Now I have return max of left or right comma 0. Yeah, I have returned this. So what I have returned, we do not have to return both. We have to return either left or either right. Correct, no? So I'll return here max of left val comma right val or 0. I don't want to return negative value. I have to write max val, right val or 0 plus current val right? Yeah, I have returned max dot. That's it. Now I'll call the function self dot max sum, and with the value root, and I will return what, self dot max sum. That is the solution. So let's test case it, or let's try run it, right? So I have an example, this 1, 2 and 3, right? So root is defined for 1, yeah, I'll return none. I'll not return none. I've created a max sum value, that is infinity, minus infinity. So self dot max sum is equal to root, not rot, root, RWT, root. Self dot max sum is root, and self dot maxsum is root. I'm calling a function called maxsum with the root. If root is not defined, return 0, but root is defined here. 1 is the root, So we will store the value, current value is equal to root dot value. You don't need to do that, but I have done this. Current value is root dot value. I have stored in a variable. I'll call the left of the root. So left of the root is what? 2. So I'll call 2, right? Now again 2 is defined. I'll try to get the value of that root. The root is 2. Current value is 2 here. So current value is 2 here, right? And I'll try to get the left of 2 as well. So left of 2 is null, so it will return 0, and right of 2 is also null, it will return 0. So self dot max sum is equal to, max sum is minus infinity, comma, left value, what is the left value for 2 is 0, right value for 2 is 0, and current value is 2. So max sum is 2 currently, because it is 2 is greater than minus infinity, right? And I will return either left or right of the two. So left value 0, right value 0. दोनों में से max, what is the max between them is 0 only, and 0 plus 2 is 2. So this particular node or this particular subroot is running 2 to the 1, right? Now we have traversed left is 2 for root 1, we'll go right for root 1. So what is the right for root 1? We have max root dot right, and root dot right is 3. So root is defined, so this will not return 0. What is the current value? That is 3. Now we'll try to go to left of 3. The left of 3 is 0, and right of 3 is also 0, right? So left value and right value for 3 will be coming as 0. So what is the max sum? So max sum is currently, you know that we have stored 2 as a max sum. So 2 comma left value is 0, right value is 0, and current value is 3. So what will the maximum now? Maximum will be 3, because 3 is the maximum. Now I have written one of them of root. So for 3, left is also 0, right is also 0. So left comma right 0 comma left comma right 0 comma 0 comma 0. What is maximum of all? It is 0 plus root dot value is 3. So this node is returning 3, right? Now we have find left value for 1 is 2, right value for 1 is 3, and sum. What is the maximum now? Maximum will be the maximum, like max of maximum, comma left value, that is 2, right value, that is 3, and plus current value, that is 1. So what will be maximum will be 6. So it will update maximum, because 6 is greater than 3, right? So it will update the maximum. Now I'm calling the max, that is I'm returning either one of them, okay? Either one of them, not both. So I return either 1 2 or 1 3, because I do not have to return like all 3, correct? No. So I'll return 1 comma 3. Why? Because 3 is maximum than 2, right? So this max will return 2 3, and 3 plus 1, that is 4. So for this root, this consider this is a subroot. With this subroot, max is 3 plus 1, that is 4, and we do not have any root of this, so that is 4. So currently we have what is maximum till now, that is 6 here, right? So I'll just returning the maximum. We have this test case as well, but due to time constant, I will not dry run for you, but you do by yourself, and let's submit this question. Okay, so I have to call using self dot maxsum, not maxsum. So just remember that whenever you calling a function, use self. Self is like telling that it is defined in this class called solution. Yeah, it is working. I have accepted. It has been accepted. Now submit it. Okay, it is wrong answer now. What is the mistake I have done? So for this 2 comma minus 1, what is the max? Okay, so let me use this test case. So this particular root will be returning minus 1, but I don't want to return minus 1. I want to return 0. So let's go to 2. We have 2 dot left. So left we got minus 1. Then left value is minus 1. sorry, left value of 1 minus 1 is 0, right value of minus 1 is also 0. So max sum is what? Max sum is 0. Left value of minus 1 is 0, right value is minus 1. So max of n plus current value. So what is the max value currently here? That is minus 1, and it is greater than minus infinity, correct? No, yeah. Now it had written left comma right value comma 0. What is the max of both? So for this, left is 0, right is 0 plus root right value. But I don't want to return negative as a max, so I will do this much thing as well. So max of this as well, comma 0. So what will happen? This will sum this value, and again, so after summing them also negative, I will return 0 because we do not want to take negative value. Okay. So let me return it again. Now it is working now. Now it has been accepted. Yeah. So we had done this mistake because we do not want to take any negative value from the subroot. So that was the problem, and we have solved this. Thanks for watching, guys. And I'll be doing this video. I'll be doing this stage until I get job in the big tech company, and I hope I get the job. I will get the job. I do not hope I'll get the job. Until I'll grind like this, and I'll do daily lead code, blind 75, and I'll try to understand the pattern concept, not just the question. So if I do that, I'll be improving a lot, and you also do the same. And thanks for watching. We'll meet tomorrow. Thank you. Bye bye.